Section 4.4 is applications of linear systems. Our goal is to represent constraints by equations or inequalities and by systems of equations and/or inequalities and interpret solutions as viable or non-viable. On page 255, we have you can solve systems of linear equations using a graph, the substitution method, or the elimination method. The best method to use depends on the forms of the given equations and how precise the solution should be. You can choose graphing when you want a visual display of the equations or when you want to estimate a solution. You can choose substitution when one equation is already solved for one of the variables or when it is easy to solve for one of the variables. Choose elimination when the coefficients of one variable are the same or opposites or when it is not convenient to use graphing or substitution. Systems of equations are useful for modeling problems involving mixtures, rates, and break-even points. The break-even point for a business is the point at which the income equals expenses. The graph shows the break-even point for one business. Notice that the values of y on the red line represent dollars spent on expenses. The values of y on the blue line represent dollars received as income. So y is used to represent both expenses and income. Here is our line for expenses. Here's our blue line for income. The point where these two cross is called the break-even point. Everything before this point is considered losing money, and everything after is considered making money. Example 1 says a fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? We can let X be the number of hats and let Y be the amount of money. If we want to look at the cost, we have Y equals the $1,400 the designer spent on advertising and the $5.50 per hat that the designer spent on material, which can be represented by plus $5.50 times X. To find the income, we have Y equals $12.50 times each hat, or $12.50X. To find the break-even point, we want the cost to equal the income. This occurs when $1,400 plus $550X equals $12.50X. Our goal is to get the X all by itself, and to do so, we need to get all the X's to one side. So we can subtract $550X from both sides. 550X minus 550X is 0, and we're left with 1,400 on the left. 1250X minus 550X is 7X. Now our goal is to get rid of the 7 by dividing both sides by 7. 7 divided by 7 is 1, so we're left with 1X or just X. 1,400 divided by 7 gives us 200, so we have X equals 200. Therefore, the designer must sell 200 hats in order to break even. The work for this problem is written out on the next few slides. And now I would like you to try homework number 1 on page 256. A bicycle store costs $2,400 per month to operate. The store pays an average of $60 per bike. The average selling price of each bicycle is $120. How many bicycles must the store sell each month to break even?